Alright, so in this video we're going to be kind of putting a bow on everything. We're going to do one of these polynomial problems. It's one of the longer ones that we've seen in this course thus far. Whoops. But what I would encourage you guys to do is go ahead and hit pause on this video. When you hit pause on this video, work it out, and then go ahead and hit play and see if you get what I got. So the first thing we're going to do here is find the degree of the polynomial. It's very helpful for finding maximum number of zeros, turning points, and helps us with the end behavior. When this is expanded out, I'm just looking for the highest exponent. I can see that the highest exponent is 4. So the degree of this polynomial is 4. The next question asks us to look at limits. So this says the limit as x approaches infinity. So this is what's happening on this boundary. And this says the limit as x approaches negative infinity. So what's happening out here? We have to be able to figure out the end behavior. We need to know the degree of the polynomial, which I just found, and that degree is even. What an even polynomial is going to look like is either a parabola opening upwards or a parabola opening downwards. How do we know whether it's opening up or down? Then we look at the leading coefficient. I can see that the leading coefficient in front of this one is 1. That is a positive number. Positive coefficients opening up, negative coefficients open down. So this is what the end behavior is going to look like on the edge of this graph. How do we answer that in terms of this limit notation? Well, this is saying what is happening out here as the x's go to the right. What is happening to the y's as the x's go to the right? Which way is this arrow pointing? Are these y values going up or down as the x's go to the right? The x values or the y values are going up. So as x's go to the right and get bigger, the y's are also going up and getting larger as well. When we look at what happens here on the left, that's when x goes to negative infinity. So the limit as x goes to negative infinity, what are we doing to these y values? As x is going to the left, the y values are going up. So as x tends to negative infinity, y is going up, so y is going to positive infinity. You can see that that arrow is going up, those y's are going to get bigger. So this is how we answer that in terms of that end behavior. The next question asks us to, using your calculator, find a whole number 0 and list it below. So we're going to go ahead and put this in the calculator. If you haven't yet, go ahead and hit pause on the video and put it in the calculator. And when we put this in the calculator, I take a look, and here's my graph, and I can see that I have zeros at, ooh, that's not a nice number. Ooh, that's a good one, 3, and then 4.732. So we're looking for a whole number 0 to use for synthetic division. So we found one, it was 3. So the whole number 0 was 3. And that is a 0. So we're going to use the 0 from the previous part to perform synthetic division on g of x. Then we're going to find all of the other zeros. So let's do synthetic division. 3 goes in the box. Remember, if it's in a factored form of x minus 3, you would flip it. But since we just have the 0 already of 3, that's the number that goes in the box. Now we write the coefficients in front of our polynomial that we started with. So what's the number in front of x to the 4th? It's 1. What's the number in front of x cubed? It's negative 12. What's the coefficient in front of x squared? It's 51. What's the coefficient in front of our x term? Negative 90. And then our constant term is 54. We draw a line, and we're going to go through this process where we divide this polynomial up. So we bring the first number down. 3 times 1 is 3. Negative 12 plus 3 is negative 9. Negative 9 times 3 is negative 27. Negative 27 plus 51 is 24. 24 times 3 is 72. 72 plus negative 90 is negative 18. Negative 18 times 3 is a negative 54. So my remainder is 0. What we did here is we started with that original x to the 4th polynomial. We divided it by a 0 of 3. What that would look like in the factored form is x minus 3. And then our resulting cubic polynomial, because it was a 4th degree, we're going to break it up into a 1st degree times a 3rd degree. And these are the coefficients in front of our cubic polynomial. So it's going to be 1x to the 3rd minus 9x squared plus 24x minus 18, and then with a remainder of 0. This was helpful for us. I got this down from a 4th degree to a 3rd degree, but I can see I can't factor this completely yet because this isn't a quadratic. So what do? Well, we could put this into the calculator and look for a 0, but I want to go back to our original function. Take a look at this 0 of 3. What is it doing on this x-axis? Is it touching or is it crossing through, or is it touching and bouncing? So right here you can see that it is not crossing through the x-axis. What does that tell us about this 0? That tells us that the multiplicity of that 0 is even, right? Remember, odd multiplicities cross through, and even multiplicities just touch the x-axis. If this is an even multiplicity, I know there have to be at least 2 factors of x plus 3 in there. So I know that since it touches at 3, that I can use division for this again. So I'm going to put 3 in the box again because we know it's even multiplicity. So now we're going to divide 3 by this resulting polynomial. The coefficient in front of x cubed is 1. The coefficient in front of x squared is negative 9. Our x term is 24. And then our constant term is negative 18. We leave some space. We bring the 1 down. 3 times 1 is 3. Negative 9 times 3 is negative 6. 3 times negative 6 is negative 18. 24 minus 18 is 6. 3 times 6 is positive 18, negative 18 plus 18. Again, we get a remainder of 0. That's how we know that was a factor. So we broke this up. Let's keep what we had. We had an x minus 3. We just divided by another x minus 3. And then our resulting polynomial is x squared minus 6x plus 6. Okay, so we have 2 linear factors of x minus 3, and then we did finally get down this down to a quadratic, which is x squared minus x plus 6. Now, I'm going to try to factor that. What are factors of 6 that add to negative 6? That's not, I don't know that we can factor that, because factors of 6, well, I have negative 6 and negative 1, but those don't add up to negative 6, those add up to negative 7, so we're not going to be able to factor this. So if we can't factor it, what else do we do with a quadratic? We use the quadratic formula, right? So I'm going to take this, we're going to bring this up here, and we're going to work with it. So I'm going to take the polynomial x squared minus x, 6x plus 6, and we're going to work on the quadratic formula. Remember, this is the quadratic formula. It's negative b plus or minus square root of b squared minus 4ac all over 2a. And in this polynomial, a is equal to 1, b is equal to negative 6, and c is equal to positive 6. Let's plug that into the quadratic formula. So it's negative 6 plus or minus square root of negative 6 squared minus 4 times 1 times 6 all over 2 times 1. Let's simplify this. Don't try to work this out in one step. Take this and break it down. Negative 6 is positive 6, plus or minus square root of negative 6 squared is 36, and then negative 4 times 1 is negative 4. Negative 4 times positive 6 is negative 24. All over 2 times 1 is 2. All right, 36 minus 24 is 12, so this becomes 6 plus or minus square root of 12 over 2. Now you might think we're done here, but we need to take a look at radical 12 and ask if we can simplify that at all. Square root of 12, what are 2 numbers that multiply up to 12? 4 and 3, right? So this becomes square root of 4 times 3. Can I take the square root of 4? Yeah, it's 2. So we're going to evaluate the square root of 4, and what we're going to get here is 2 radical 3. So this becomes 6 plus or minus 2 radical 3 over 2. And now, can I cancel anything outside of the radical? Remember, you can never cancel underneath a radical. You have to bring things out first. And you can see I can divide each of these terms by a 2. So what we end up with here is 3 plus or minus square root of 3 over 1, which I don't really need. So it's really 3 plus or minus radical 3. So these are 2 answers, right? It's going to be 3 plus radical 3 and 3 minus radical 3. So down here, it asks us to list all the zeros. So our zeros here are going to be x is equal to 3, right? Because that was our first one we found. X is equal to 3 plus radical 3. And x is equal to 3 minus radical 3. We had, remember, this one is the one that's multiplicity 2, right? I'll make note of that. Write g of x in completely factored form. So to write it in completely factored form, it's going to be x minus 3. We had 2 of them, right? So it's x minus 3 squared. And then it's going to be x minus 3 plus radical 3 and x minus 3 minus radical 3. You can see that I do end up with something that is degree 4, and so was my original polynomial. Now it says use the information you gathered about g of x to graph the equations. So I'm going to rely on my calculator a little bit here because I know I could evaluate these. So it looks like this must be 3 minus radical 3 and this must be 3 plus radical 3. So 1.3 and 4.7, I'll put those on here. So 1.3 is something like right here. 4.7 is right here. And I know I also have a 0 at 1, 2, 3. Remember, we knew our end behavior looked like this, right? And then let's think about this. We could look at the graph to help us, but this is multiplicity 1, so it passes through, 3 minus radical 3. 3 is even multiplicity, so it touches, and it's going to head down, and it's going to cross through again. And that's a really ugly version of this graph. It looks a lot better here, but I did draw a rough sketch of that.